Hi, I'm Stormtracker 16 Chief Meteorologist Kurt Aaron. We're here at Pine Hills Country Club in Taylor for another episode of Cloud to Ground. We're even joined by some feathered friends, as you can see here in the background. The course is in great shape, but the weather's a little hot. As you know, this week is going to be a scorcher. We're talking high temperatures, upper 90s, even low 100s. That can be problematic, so please check on elderly who may not have air conditioning. Also, don't leave pets outside in temperatures like that. We just want everybody to be safe. And speaking of toasty, well, we actually had some kids who asked us questions about the oceans. So let's go to a place that isn't quite so hot. Hi, and welcome to the WNEP Backyard. I'm Chief Meteorologist Kurt Aaron, and you know, sometimes I come out here and I like to just look at the waterfall. I like to see the water, not only the sound of the waterfall, but you know, water's a critical part of our lives. And that leads us to this very next question.
I want to know, how do ocean currents affect climates?
Great question. So how do ocean currents impact our climate? It's very important. We'd be in big trouble if we didn't have those ocean currents. One of the main things helps keep our planet warm. For this and much more, let's go back into the severe weather set. You know, here in the severe weather set, this is where we deal with severe weather all year round. Wintertime when we have snowstorms, and the summertime when we have tornado watches, warnings, and also severe thunderstorm warnings. But this week, we have excessive heat warnings issued by the National Weather Service. So we've issued a weather impact alert because the sun is really hot this time of the year. We're going to have heat indices getting over between 105 and 110. That's the index on how it feels. Okay, so now that we're in this nice air-conditioned set, let's go back to the original question. Ocean currents, and how do they impact our climate? They are very important. Think of this, the ocean is like, especially at the equator, like a giant solar panel. So it's collecting the heat, the radiation from the sun, and it allows that heat to be dispersed right throughout the planet, up into the North Pole, up down into the South Pole, Arctic, Antarctic as we call them. That's a key role in our climate. Now, to break this down even more, let's go over to the big board. Okay, so back here at the big board, I got another graphic that I want to show you. This is very interesting. When we talk about ocean currents, it's like a conveyor belt of energy, okay? So what's happening is the sun is heating the oceans, and then we get these currents. In the northern hemisphere, they rotate clockwise like this. So it transports warmer water from the equatorial region and brings it up and around into the colder parts like the Arctic. Now, this whole system is very, very important to our weather patterns. How does this happen? Well, it's a combination of a number of things. You have winds, you also have temperature, Earth's rotation, tides. There's many factors that go into creating ocean currents, but just know this main thing, they are very important to our climate. So once the warmer water follows along, and notice it mainly goes along the coastline. Once it heads up towards the Arctic, it cools and then comes back down towards the equatorial region and warms up again. Now, that's the northern hemisphere. It's different in the southern hemisphere. If you look down here, the process is same. It's different in the aspect that instead of going clockwise like it does in the northern hemisphere, in the southern hemisphere it goes counterclockwise, doing the same thing but in a different direction, which is very important. And if you look at that, again, same process, following very close to the coastlines as it does that. So that's image number one. I want to show you another one. Now, along the lines of transporting warm water and precipitation from the equator towards the poles, and then cold water from the poles back to the equator, the oceans regulate global climate. And that helps counteract the uneven distribution of solar radiation reaching the Earth's surface. What do I mean by that? Well, without currents in the ocean, regional temperatures would be much more extreme, talking about super hot right at the equator, and then frigid temperatures as you get closer to the poles. And much less of Earth's land would be habitable. So currents are a key role in making sure we are safe. So you see, it's very important for us to have ocean currents. It not only helps regulate our temperatures, but it also keeps us alive here on the planet and allows us to live on a bunch of different continents that we may not be able to if it wasn't for the ocean currents. So now let's talk about next week's science question. Go ahead.
My question is, why is weather different in some places because of the mountains or other landscapes?
That's a great question because mountains, especially big ones, do impact climate. We're going to talk more about that in our next episode of Science Class. Until then, have a wonderful day. Thanks for watching. Hope you learned something. Science class dismissed. Thanks, kids. Great questions. You know, you always keep us thinking about what you're going to ask next, and we really appreciate it. And that's true for our friend Joe Snedeker. In his lightning round, he gets asked about a cold blob in the North Atlantic. Take it away, Joe.
Hi folks, and welcome to the Lightning Round. Remember, we answer your questions, and this one came in from Jeff from Sunbury. Now, sometimes I can go through 3, 4, 5 questions, and they're quick and easy. This one's going to be like a mini science class. Are you ready for it? I hope so. All right, Jeff, I absolutely enjoy and love your segment. Thanks for all the hard work. Joe, I know it's a short segment. You are correct, but could you give me your opinion on the cold blob in the North Atlantic? Oh my goodness. Jeff, there it is. That's an anomalous puddle of cold ocean water. Now, when I say puddle, keep in mind the size of that is a good chunk of the United States. It would be like the size of 3 or 4 states of Texas. So why would that one semi-permanent blob be there in recent years? So here's what's happening. The planet as a whole has been warming up over the last 100 years, thanks to man's influence on climate. Carbon dioxide traps heat. We're putting out more carbon dioxide. The earth is warming up. The oceans are warming up. The land is warming up. But one thing that's warming faster than everywhere else is the Arctic. So what's in the Arctic? Ice. So what's happening, we're melting the ice at an accelerated rate. And guess what? That water that's melting from the glaciers, think about this. Salt water is heavy, fresh water is light. So we're melting that glacial ice, which is light, and it sits on top of the heavier ocean water. So now, here is the Gulf Stream, bringing all that warm water north, and it takes it to Europe and gives them a nice mild climate. Warm Gulf Stream, warm Gulf Stream. But now what's happening on top of the warm Gulf Stream, all that cold meltwater from the accelerated melting of the glaciers is now sitting on top of the Gulf Stream. That's not good. It may be suppressing the Gulf Stream. So the warm salt water moves north, loses its heat, becomes sequestered because of the cold polar water that sits on it and is lighter, and that could be a result of the Gulf Stream being suppressed. And if that continues, this cold blob, and the Gulf Stream shuts down, goodbye nice warm climate in Europe. Their temperatures can drop 5-10 degrees and lead to almost like a mini ice age. This could be a major global disruption. I don't want to scare anyone. It could be years, decades, or even centuries in the making. But if this continues, we could be having what's called a negative feedback loop, meaning we're warming the planet, but that causes the ice to melt, suppresses the Gulf Stream, and shuts down what is normally a warm flow of air and water all the way to Europe. Yeah, all because of us and our pollution of carbon dioxide into the atmosphere. That is one theory on the cold blob. We'll see how it goes. I don't want to ruin your day. Keep the questions coming. They don't always have to be dark and intense, but remember, weather@WNEP.com is the email. Let's talk about warm blobs and the summer still to come, right? And make it a good day.
Thanks, Joe. That's great analysis. Now, many of us have our sights set on the upcoming holiday weekend where we're celebrating 250 years of freedom as a nation. Anthony and Allie also take on the question of 4th of July. That's coming up in just a few minutes. Hi, and welcome back to Stormtracker 16's Cloud to Ground. I'm Kurt Aaron. You know, we're talking about record heat this week as we go into the holiday weekend, July 4th. Our very own Allie Gallo will compare it to how this 4th of July and possible record heat compares to previous years. Take it away, Allie.
We're in the middle of a heat wave here in Pennsylvania. It's not only hot, but very humid too, and this trend is going to continue into the holiday weekend. We will likely hit 90 degrees again on the 4th of July. That's above average, but we're not going to be breaking any records this Independence Day, not even close. This week, we're taking a look back at what the weather typically looks like for the 4th of July here in northeastern and central Pennsylvania.
This is one of the hottest weeks of the year on average, and this week we are certainly feeling that. The average high for the Scranton area right now is 84 degrees, and the average low is 62. So even our mornings this week have been mild too. The hottest high temperature recorded for the 4th of July here in the Scranton area is 99 degrees. That happened in 1911. The coolest Independence Day on record was in 1978, when it was only 61 degrees for an afternoon high. The low that year was 50 degrees, which is also one of the chilliest low temperatures recorded for the holiday. In 1986, the morning low for the 4th of July was 46 degrees. That is the coldest temperature ever recorded for the 4th here in the Scranton area. We have hit 90 degrees for the 4th of July 15 times since record keeping began more than 100 years ago, most recently in 2020 and in 2019. Last year was the coolest Independence Day we've seen in the past 10. The high was 78, but it was a very sunny, very nice day. In the years before that, we've been in the 80s and 90s for highs, so right at or above average each year. But in 2015, it was 68 degrees, and that was one of the coolest 4ths we've ever seen. It was only ever cooler 6 times. That was also one of the rainiest 4ths we've ever had, too. 0.83 inches of rain fell that year, which ranks it at number 5. At number 1 is 1925, 101 years ago. 1.88 inches of rain fell here in the Scranton area on July 4th, 1925. In 2023, it wasn't a stormy 4th, but it was a very active holiday weekend. On Sunday, July 2nd, 2023, severe thunderstorms developed across much of northeastern and central PA. And meteorologists with the National Weather Service later confirmed multiple tornadoes touched down, including at least 3 in Union County and 1 in Lackawanna County here in Dixon City. Here in Kelly Township near Lewisburg, multiple businesses were destroyed, including this one, ironically. Light It Fireworks. It was an EF1 tornado that hit this part of central PA, and at the time, Newswatch 16 spoke to George Rutherford. He lost his fruit stand of 37 years.
It started raining hard and got a little windy and didn't think nothing of it, but then all of a sudden I seen the trees break off over there and flying through the air. I grabbed my girlfriend and grabbed a hold of her to keep her from getting hit, and it came through and just left loose. Next thing I know, we're on the ground and the building's on top of us. It was 30 seconds, I think. It wasn't long, but it was just fast.
In Dixon City, it was an EF0 tornado that hit this neighborhood. Rob O'Malley lost the porch he built 4 decades earlier. At the time, he told us he would have never expected a tornado hit his home. And while he may not have seen it coming, he certainly heard it.
Everything you hear about it sounded like a freight train. I was in my couch. I was on the couch, she was in her chair, and it hit like that. It did happen in a matter of seconds. I would say no more than 10 seconds. I look out the window, all this stuff is flying around. It goes in dead silence.
Pat Suhanik lives on Bowman Street. She heard the tornado coming too.
It sounded so loud, and then I looked out my dining room window and I could see all this stuff floating around in the air, and then it just became so loud I started heading for the cellar.
Afternoon and evening storms are in the forecast every day this holiday weekend, but a lot of the days will end up being dry, so it is important to stay weather aware as you enjoy your 4th of July weekend. Next week, we'll take a look at heat waves and just how rare this one is here in northeastern and central Pennsylvania. Thanks for joining me this week. I'm Allie Gallo.
Thanks, Allie. Yeah, we are keeping an eye on the record books this year. This could turn out to be one of the hottest 4th of July weekends on record. We'll see. We'll see if that happens. The sun is certainly scorching us right now, and the sun has a plethora of colors. But as we celebrate 250 years as a free nation, our own Anthony Bordenero talks about why the brilliant colors of the fireworks look the way they do.
Picture this. You're by a lake. It's Saturday night, the 4th of July, America's 250th, and you hear those fireworks explode. And then you think, how does it all work? Welcome to another episode of Whiteboard Weather. Today we're discussing how fireworks work. And it's a lot of chemistry, and we'll save the nitty-gritty and we'll focus and do a little weather tie-in. But first, I want to talk about how the firework setup goes on. And the main key thing I want to say today is this green is actually yellow because we don't have yellow markers here in Whiteboard Weather. But for the rest of this episode, that's yellow. Okay? And the darker green is green. But what I want to do is show you how the fireworks work. So here's your boat, and I want to zoom in and show you exactly what's happening here. So there's a tube, a sphere that's in the tube, and you get a bunch of pressure buildup beneath here. The gunpowder, that explodes, and then this lifts, shoots up, and becomes your firework. Now this ball has a little timer to it, a little fuse, as you could say, and once that explodes, it lets off all the fireworks, and they're little balls that are located in the firework. And depending on its pattern is depending whether it's a heart, whether it's a unicorn, which may be a little bit difficult, whether it's just one of these classic little fireworks. But there's also something different. How do you get a red versus yellow versus blue firework? Well, let's explain it. Let's flip the whiteboard and let's show you. So different elements react differently underneath that pressure. The two that form the red are strontium and lithium. The one that forms the yellow is sodium, your salt. And the ones that form the blue are copper. Now, copper is the most expensive type of firework. That one, it's costly to get a blue, and also it's harder to get blue based on its chemical elements. So if you're curious, blue is generally the hardest to get, and red are the easiest. So for this fireworks season, I'm curious, count the reds, count the blues. I'm wondering if your local fire display is cheapening out. But these react differently with different elements. So we got to break it down into the atom of the element. Now, different atoms they're called electrons. You're probably familiar. And this is a diagram of an atom. In the middle is the nucleus. That's where you have your protons, that's where you have your neutrons. The first shell of electrons, the first shell can only hold 2. The next one can only hold 8. And then it goes up and up from there. But what makes these metals special is that they only have on the outer shell 1 or 2. So they're not full just yet. And when you put them under intense heat and intense pressure, some of these electrons bounce to the outer shell briefly. And that's what creates your explosion. That's all it is. Nothing more to explain. That's basically what it is. Now, some have 1 outer shell, some have 2, some have 3, some have 4. So strontium has 5 shells, sodium has 3, copper has 4 shells, and that basically determines how big the explosions are. Here's a brief interjection because I didn't explain why blue is blue and why red is actually red. It all happens because of the energy of the explosion. Remember last week with the rainbow episode, I was talking about how blue has high energy? Well, that's a similar case with the explosion for blue fireworks, and red has lower energy, and that's why it is red. Let me show you. Blue has a shorter wavelength in the visible light spectrum. That's what makes it blue. The explosion of red has longer wavelengths, and that's what makes it red. I just thought that interjection was important. There's a reason why different colors are different things. Now let's keep it rolling. Now you're probably wondering, okay, Anthony, there's red, there's yellow, there's blue. Well, we have a bunch of other colors. How do they work? Well, you've heard of the color wheel before, right? If you combine red and yellow, you get orange. If you combine yellow and blue, you get green. And then if you combine red and blue, you get purple. Isn't that fun? So they literally blend and mix these different elements and that become fireworks. Or in green's case, you can use an element called barium, or in orange's case, you can use calcium. So yeah, that's simple of the simplicity of fireworks. And yeah, so whenever you're looking out, enjoying the fireworks, you can think an element called strontium or lithium for the red. You can think sodium, your table salt, for the yellow. And then you can think of copper for your blue. So thanks for tuning into this edition of Whiteboard Weather, and we'll move on to the next segment.
Great explanation. Thanks, Anthony. And just be careful if you are lighting off fireworks this holiday weekend. We just want everybody to be safe. We don't want any issues at all. Now, Jeremy Lewan is watching some things that are firing off in the sky between us and the stars. He's got that coming up next in Cloud to Ground. Stay with us. And welcome back to Cloud to Ground. I'm Kurt Aaron. You know, you can't see them when you look up in the sky, but trust me when I tell you this, there are thousands of them up there. Some work, some don't work. What am I talking about? Well, you are not going to believe this until you see it. Here's our own Jeremy Lewan.
After last month's meteor-triggered sonic boom near Boston, a lot of people started looking up. But while that meteor was a natural visitor, what's really surprising is what's already up there. Every dot you're seeing here is a tracked object orbiting Earth. Some are active satellites that help power GPS, internet, weather forecasts, and communications. Others are dead spacecraft, spent rockets, or fragments from collisions and breakups over decades of spaceflight. Low Earth orbit, the region of space closest to our planet, has become increasingly crowded. Space tracking companies like Leo Labs monitor some of the more than 25,000 objects currently in low Earth orbit to help operators avoid potentially catastrophic collisions. The meteor over New England burned up naturally in our atmosphere, but most of these objects won't. That's why scientists and satellite operators are racing to manage the growing traffic jam above our heads. With this visualization, you can filter by active satellites, and you can also toggle on and off the debris layer to see just how many things are orbiting our planet. But also with the satellites, you can filter them by country of origin to see which ones are owned by which countries, the US, Japan, India, for example. And what's really cool is if you want to, you can follow one individual satellite and see its track of orbit. If you'd like to scroll around on this website for yourself to see what's orbiting above our heads, head to WNEP.com. The meteor over Boston was a reminder that space can surprise us. But the bigger story may be the thousands of objects we've already left up there, because the next sonic boom from space might not come with a natural rock. It might come from humanity's own orbital leftovers, and that's a problem that's only getting bigger. Jeremy Lewan, Newswatch 16.
Thanks, Jeremy. And I want to thank you. You know, it's really cool every week. We can't wait to see what questions, what things you want us to cover. So every week it's like opening up a gift. And we appreciate that you do that for us. On behalf of the entire Stormtracker 16 team, I'm Kurt Aaron saying thank you. Also, have fun this holiday weekend as we celebrate 250 years as a nation that's free. It's such a wonderful country, and we hope you go out and enjoy in the celebrations. Once again, thanks for joining us, and we'll see you next week on Cloud to Ground.